Now we will discuss about the anti-Markovnikov rule. It is also one of the reaction where two reactants are one of the reactant is unsymmetrical alkene. One of the reactant is unsymmetrical alkene. Okay, and number two is HBr. Here also the addition of HBr takes place. Here also the addition of HBr takes place. But how? In the which way the HBr attached with the double bonded carbon atom? That is the main matter to focus here. Okay, so let we start the mechanism of the reaction. And one more thing, that is number three. The reagent used here is peroxide. The reagent used here is peroxide. The formula of the peroxide is C6H5 bond C double bond O. Okay, and then O, फिर C double bond O bond C6H5. So this is the formula of the peroxide. In the presence of peroxide, anti-Markovnikov rule is followed. So when the reaction is given in the question paper, there in the above of the arrow it is written that peroxide. So in the presence of, when the addition of HBr takes place in the presence of peroxide, then we easily understood that it is the application of anti-Markovnikov rule. Okay, so how the reaction takes place, let's see below. Okay, if the unsymmetrical alkene is CH3CH double bond CH2 and the reaction is something like that, HBr will be added here, HBr will be added here, and in the presence of peroxide the reaction takes place in the following way. The negative part of this hydrogen halide will attach with that carbon atom which contains greater number of hydrogen atoms. So between these two carbon atoms, double bonded carbon atoms, this carbon contain 2 hydrogen and this carbon contain only 1 hydrogen. So the negative part will attach with the carbon atom which contain more number of hydrogen atoms, and H plus will attach with this carbon atom. So the product will something like that, CH3 CH2 CH2 Br. In the case of anti-Markovnikov rule, this product will be the major product. Okay, so this is the general trend, but if we examine the reason behind this, then we see the another matter. What is the matter? The matter is free radical mechanism takes place here. Free radical mechanism takes place here. So we have our focus, we keep our eyes on the free radical mechanism of peroxide by which the reaction takes place. Okay, so first of all we draw the structure of peroxide. That is something like that, C6H5 bond C double bond O bond O bond O bond C double bond O bond C6H5. We know that free radical mechanism takes place and the bond cleavage takes place something like this, in this way, and this bond will form two radicals here. So in the first stage of the reaction there will be two C6H5 C double bond O dot. So it is a radical, and here it is also a bond. In the next step the bond cleavage in this place, and the next product will be 2 C6H5 dot plus CO2. This will form the CO2. Okay, in the next step, so this is the first step of the mechanism, free radical mechanism. In the next step we will see C6H5 dot react with HBr, and HBr will the bond between the H and Br will clipped like this, and it will form C6H5 plus C6H6 plus Br dot. So Br dot is the free radical here. In the next step the unsymmetrical alkene comes into play. Unsymmetrical alkene is CH3 bond CH double bond CH2. It will react with Br dot. Okay, it will react with Br dot. So this bond will break here. This bond will break here, and the product is something like that. CH3 bond CH on the CH, the radical will produced, and the next product will be CH2 Br. This will produce one dot, this one dot, and this dot of the on the Br will form this bond, okay. So CH3 bond CH dot, so here the dot will produce, radical will produced here, radical will produce here, okay. And in the next step, the HBr react with it, and this bond will break, okay. And Br will attach here with, and the H will attach here with, and Br will be in the form of radical. So the product will be CH3 bond CH2. Focus on these portions. That was CH dot. This H dot will attach with it, attack with this CH dot, and it will form CH2, the another hydrogen bond, another bond with hydrogen atom, and the next portion will be CH2 Br will be attached here with, and Br dot will be in the form of free radical. So this is the product, and this is how the major product is formed. Now we can understand properly the reason behind the anti-Markovnikov rule, which mechanism is involved here. Okay, thank you, good night.